With the emergence of generative AI tools, people are increasingly interested in leveraging their reasoning and code generation abilities to develop intelligent agents that can interact with environments. One promising direction in this trend is to help non-experts step ahead of the steep learning curve of current 3D tools and enable them to build 3D interactive environments through conversation with intelligent programming agents. However, one challenge we still face is that we do not know how people would prompt these agents when authoring and programming 3D environments. Without such knowledge, we may build tools that do not match users' expectations, which could lead to human-AI collaboration breakdown. We are therefore interested in understanding how users would prompt to create interactive 3D environments to reduce potential user expectation and AI tool design mismatch. We conducted an elicitation study where participants were placed into a virtual environment with certain initial state. We then show them reference videos depicting desired changes to the initial state, like this cat jumping away. We collected spoken prompts that participants would like to use to trigger these changes. For example,
when somebody approaches the sofa, make the cat jump onto the coffee table.
We also collected their other behaviors like gestures. Following the Wizard of Oz method, we presented simulated outcomes in the 3D environment to the participants so that it appeared that the system created the scene in response to their prompts. Our reference videos included scenarios involving object creation, modification, and their dynamic behaviors. Participants provided their expected input in two conditions. In situ participants were immersed in a virtual environment through a head-mounted display, while ex situ participants used a desktop computer. We identified 4 key patterns in participants' behaviors. Here, we will briefly describe the first 3. First, participants expect the agent to be aware of the presence of themselves, the objects, and environments, and also the spatial relationships between them. When seeing this reference, which showed a chair automatically making space for a person approaching, one participant said,
"When a person reaches the chair, make the chair face towards him,"
suggesting an assumption that the agent should be aware of the relative spatial relationships between people and objects. In situ conditions, participants often accompany their prompts with explicit references like pointing or implicit references like head directions. In this example, the participants needed to move a box. He used pointing gestures to direct the movement.
Okay, put this box with circle texture over there.
Participants anticipate that the agents keep track of their interaction history. Here, in the previous step, the participant had prompted the agent to arrange the furniture. To align the furniture against one side of the wall, some participants simply asked to restore the objects to their prior state, such as
put them back.
Based on these findings, we also built OSTAD, a programming agent prototype that has embodied knowledge, understands embodied prompts, and keeps track of previous interactions. In this demo, the user says,
"Put a coffee table in front of me and a lamp behind it. When I point at the lamp, turn it off."
OSTAD synthesized the code accordingly. After execution, the objects are placed in front of the user with the specified interactive behavior attached. Please refer to our paper for more details about the elicitation study and the prototype. Thank you.